Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Further Mathematics, Paper 1, which is a Further Pure Mathematics 1 for October-November 2023, and the code is 9231/11. So if you enjoy watching this video, please like the video and subscribe to the channel, and then share this channel with your friends. Okay, or you can just click the thanks button below the video to show your support to this channel. Thank you. So let's start the question number 1. Okay, question number 1a, by considering square of r plus 1 minus r squared, use a method of differences to prove this summation. Okay, so we will start with r plus 1 squared minus r squared. Now, for your information, the square of two terms, it will be a square plus 2ab plus b squared. Okay, this is the quadratic expansion. So then from here, I will be getting r squared plus 2r plus 1, then minus r squared. So the r squared will be cancelled off, and you will be getting 2r plus 1. Okay, so now when you look at this summation, r from 1 to n. That means now I have to take summation both sides. So probably I will just rewrite. Okay, so now by taking summation both sides, and then the r start from 1 until n. Okay, so for the left hand side, instead of summation of summation of the 2r plus 1, I can split it into two summation. So that is summation of 2r plus summation of 1, whereby the r start from 1 to n. For the right hand side, I can just change to summation r from 1 to n of fr minus f of r minus 1, whereby my fr is basically square of r plus 1. Okay, so for the first term, I can take out the 2 in order to get the summation of r that we need to prove. So for your information, the second term, summation 1, r from 1 to n, that means all the terms will be 1. Okay, and r from 1 to n, means that there are n terms here. So that means that will be n times 1. Okay, that is the total. Now for the left hand side, according to this definition, I can just change this to fn minus f0. Okay, so here replace the r by n, then replace the r by 1. That's why 1 minus 1 you get 0. So then from here, next step is to move this n to the other side. Right, so from here I will be getting 2 summation r from 1 to n. It will be fn. Okay, now for this fn, refer to this definition. That means now I will change the r to n. That is square of n plus 1. For fn, then where f0 means that I will change the r to 0. So that is 0 plus 1 squared, that is 1 squared. Okay, then now from here, when you look at the answer, you are given half of n times n plus 1. So that means from the right hand side, I need to do expansion. Say at the same time, I will move the 2 to the other side. So it becomes divided by 2. So which is 1 over 2. And now I will do expansion for n plus 1 squared. That will be n squared plus 2n plus 1, and minus 1 squared is 1. Then from here, right, the 1 and minus 1 will be cancelled off, and then I notice that inside the bracket you have two terms. The first term is n squared, and the second term is n. Now the common term is the n, so it means that I can factorize the n. So once I factorize n from n squared, you will be getting n, and then the plus 2n will become plus 2. Okay, so this is what I get. Okay, wait, let me check. Okay. Now F0. Okay, F0. Okay, so here I miss out one term. So remember this, the n I move to the other side. These two terms, okay, these two terms are just the Fn minus F0. So when I move the plus n to the other side, I still have minus n. Okay, which means here I still have minus n. Alright, therefore, I will be getting half n squared plus. Now, simplify these two. 2n minus n is 1n. So, and then the common term is n. So, factorize the n right now. You will be getting the given answer. I mean the given form. Okay, so done for this part. Now B, given the sum, find the A in terms of n. So from summation of two terms, I can change to summation of two sum. So this is summation R plus summation A. R start from 1 to n. N equals to n. And the summation R I can change to half n times n plus 1. Then now summation A R from 1 to n, this is NA. That equals to n. And now we need to find the A in terms of n. That means the A is a subject, which means I will move this term to the other side. Okay, so my NA is n minus half n bracket n plus 1. So since you have half on the right side, I can factorize the half. And I notice that the n is also in common, so I can factorize the n. So once you factorize half n, from the first term on the right side, basically I'm getting 2. Okay, and then this half n already taken out, this minus you just times into the bracket. That means you are getting minus n minus 1. That is my NA. And now to get the A, so now I notice that the n can be cancelled off from both sides. Therefore, my A is going to be half of, now 2 minus 1 is 1. Therefore, this is my solution. Okay, now, question number 2. Prove by mathematical induction that for all positive integers of n, this summation equals to the right-hand side. Okay, so for mathematical inductions, we have few steps. So first of all, I will let Pn be whatever statement that I need to prove. So I will let Pn be the statement of the equation. So 1 plus 2x plus 3x squared until nx n minus 1 equals to this expression. So 1 minus n plus 1x degree n plus nx degree n plus 1 over 1 minus x degree 2. Okay, I let this be my Pn. Now we need to prove that this Pn is true when n equals to 1. So when n equals to 1, left hand side. Okay, so you can just substitute into here, or you can just refer to first term, up to you. So I will just write 1x to the power of 1 minus 1, which is x degree 0. Then I will get 1, which is same as the first term. Now my right hand side, it will be just replace. So refer to this form, okay, this form, and replace the x, the n by 1. So it will be 1 minus 1 plus 1, x degree 1 plus 1 times x degree 1 plus 1 over 1 minus x degree 2. Then from here, I will get 1 minus 2x plus x squared over 1 minus x squared. Okay, this quadratic function can be factorized into into 2 linear factors. So that means you are getting 1 minus x squared. And it will be 1. Okay, so from here I know that left hand side equals to right hand side. Therefore, P1 is true. Okay, now assume n equals to k is true. That means P of k is referring to, just refer to this statement and change the n to k. So I will get 1 plus 2x plus 3x squared plus until kx to the power of k minus 1, it will be 1 minus k plus 1 x to the power of k plus kx to the power of k plus 1. So just change the n to k. Now I need to prove that this is true when n equals to k plus 1. So when n equals to k plus 1, right? So now my P of k plus 1 equals to, now look at here. This is sum up to k term. That's why here k. So now I need to get sum up to k plus 1 terms. So that means it will be 1 plus 2x plus 3x squared. Just copy the sum up to k terms first. Now remember, this is k term. So when k plus 1 terms means that you need to change this k to k plus 1. Alright, so now I have to add one more term, which is k plus 1 x to the power of k plus 1 minus 1. Then, now, all of these terms will be same as this expression. Okay, so I will replace it now. It will be 1 minus k plus 1 times x to the power of k. Then plus k x to the power of k plus 1 over the quadratic. And now plus with the last term. Okay, so the last term here I will get k plus 1 x to the power of k plus 1 minus 1 is basically just k. Now what I need to prove is this k will be changed to k plus 1. Okay, all the k change to k plus 1. So now to get that form, I need to get the same denominator. Therefore 1 minus x squared, which means for the second term I need to times 1 minus x squared, then over 1 minus x squared. And now I will just write down all the numerators. So it will be 1 minus k plus 1 x to the power of k plus k x to the power of k plus 1. Okay, and then for this part, for the second term here, alright, you can just write down the numerators, all these numerators, just write it down. I will get plus k plus 1 x to the power of k times 1 minus x squared. Okay, remember, we need to get, this is k plus 1 plus 1, then x to the power of k plus 1. This one becomes k plus 1. Okay, I need to get that. So, which means now, okay, from here, I have this, which is similar to this, right? That means I need to do expansion for the squared first. So, now what to do is, I will just write equals to 1 minus k plus 1 x to the power of k, just rewrite all these terms. So k plus 1 times x to the power of k, and then the quadratic expansion, you change to 1 minus 2x plus x squared. Okay, then now, I will do expansion for this, all this group as one term and multiply. Okay, then you can see clearly the terms. So then here will be Just rewriting the first two terms. Now, this k plus 1 times x power k consider as one term. So you multiply by 1, just rewrite. And then you multiply with negative 2x. Okay, this multiply with negative 2x. So I will be getting negative 2 k plus 1. Now, here, this is x degree 1. This is x degree k. So we have a formula x degree m times x degree n. Whenever same base, it will be x degree m plus n. Okay, so from here, I will just plus together. That means you are getting x to the power of k plus 1. And same goes to the last term. So plus k plus 1. And then when we look at here now, this is x power k multiplied with x squared. That means it's x to the power of k plus 2. Then over 1 minus x squared. Okay. Now, when you refer to the form here, I need to get 1 minus k plus 1 means I will get 1 minus here. Okay, I will get 1 minus k plus 2. Then x power k plus 1. Okay, then it will be k plus 1. This one will change to k plus 1. Then x power k plus 2 as well. So which means now I need to group the term with the x of k plus 1 and x of k plus 2. So now, okay, before we proceed, look at these two terms. It will be simplified, cancel off. Okay, and then here I will have the common term xk plus 1, xk plus 1. So means that I will write 1 minus x of k plus 1. So for the orange color, I will just factorize the x of k plus 1. Then I will be getting k. K is because of here. This is a k. And then together with this whole term. So I will do expansion. Alright. That means this is going to be minus 2k minus 2. Right? Then here, you will get the last term, just rewrite. Then over 1 minus x squared. Then now, when you look at the answer here, there's a minus outside and x power k plus 1 outside. So here I will write, this is 1 minus x of k plus 1. Now from here, k minus 2k is minus k. Right? So I will get minus k minus 2. Okay, let me check. Right, I think I made a mistake over here. Here, okay, check this. I factorize x to the power of k plus 1. Factorize x power k plus 1. That means this should be plus. Because I factorize a plus. Alright, then only get the k over here. So this is plus. And then plus k plus 1 xk plus 2 over 1 minus x squared. Okay, then from here, I know that this is going to be, the minus can be taken out. So I will get 1 minus of k plus 1 plus 1. Then, okay, I have not enough space. So I will just write it here. It will be 1 minus k plus 1 plus another 1. Then x of k plus 1. Okay, plus k plus 1, x of k plus 1, then plus another 1 here, over 1 minus x squared. Alright, so put a bracket. That means now I'm getting the same term, a similar term. I would say similar form. This is k. As in my pk. Okay, which is here. Exactly the same right now. Similar form. So from here, I will just write pk plus 1 is true. So by induction, Pn is true for all positive integer of n. Okay, so that is the working for this induction. Now for question number 3, the quartic equation has roots alpha, beta, gamma, delta, and you are given these 3 summations. Find the values of b, c, and d. Okay, so from here, x degree 4 plus bx cubed plus cx squared plus dx minus 2 equals to 0. That means your a equals to 1. A is the coefficient for x squared, x degree 4. Then you have b, you have c, you have d, and then this e is negative 2. Okay, now for your information, summation alpha. Let the alpha be, okay, so your roots here, alright, all the roots, I will just say summation of the roots equals to minus b over a. And now you are given this. This is a summation of the roots. So I will say that 3 equals to minus b over 1 because your a is 1. Therefore, I found the b is minus 3. Okay, and then to use a second formula, this is basically summation alpha squared. This is summation alpha squared. Right, so we have a formula. Summation alpha squared equals to square of summation alpha minus 2 summation alpha beta. Okay, and for your information, summation alpha beta is basically c over a. So now your c remains, your a is 1. So c over 1, which is c. And now summation alpha squared is given, which is 5 in the question. Summation alpha is 3. Minus 2 times summation alpha beta is c. So which means now 5 equals to 9 minus 2c. So my 2c, you just move the 2c to the left side and move the 5 to the right side. So you will get 9 minus 5, which is 4. At last, your c is 2. Okay, now we have found 2 unknowns, b and c. We still have one more d. Okay, this means 1 over. Alright, this is summation 1 over alpha is 6. So to get 1 over alpha from the equation here, I need to, or probably I will just work out from here first. I do not refer to the original cubic quartic equation. So I will just simplify this. So which means summation 1 over alpha is 6. So 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta is 6. Now I get the same denominator for all. So which means alpha, beta, gamma, delta. So the first term, when you make it to these 4 terms in the denominator, I need to multiply with beta, gamma, delta. So for the second term, since your denominator is beta right now, I will have alpha, gamma, delta. And then the third term is gamma, then I will have alpha, beta, delta. And the last term you have delta. So my numerator should be alpha, beta, gamma. Then that will be 6. Okay, so for your information, from the quartic equation, we will get these results. Summation alpha, beta, gamma equals to minus d over a. So your d remains, right? Your d remains, then the a is 1. That means here, this is same as minus d over 1, then I get minus d. So now for this function, okay, so for this equation from 1, the numerator is basically summation alpha, beta, gamma. Then over alpha, beta, gamma, delta, basically that is e over a. So now my e is minus 2. So a is 1. That means it's minus 2 over 1. That is minus 2. So I will get that is alpha, beta, gamma, delta equals to 6. Then now I can find my d. Okay, which means when you replace, numerator is minus d, denominator is minus 2. Then equals to 6. Which means from here my d is 12. Okay, so that is the solution of this question. Now, part B, given also the summation of the cube for the roots equals to negative 27. Find the value of alpha degree 4 plus beta degree 4 plus gamma degree 4 plus delta degree 4. Okay, so from first equation. Now, not first equation, I will refer back to this quartic equation. I will rewrite this. Okay, so alpha degree 4. Now, plus bx cubed. Our b already found. B is minus 3. C is 2. Okay, D is 12. So I will rewrite all this. I will substitute all this into my quartic equation. So it means that my quartic equation is basically minus 3x cubed plus 2x squared plus 12x. So all these are BCD, and then followed by minus 2 equals to 0. Okay, so now since you are given the summation of the cube root equals to negative 27, and you need to count this, I will just substitute x equals to alpha, then you will get alpha degree 4, just replace, because the alpha is a root. And let this be second equation. Okay, then by x equals to beta, I will get beta degree 4 minus 3 beta cube plus 2 beta squared plus 12 beta minus 2 equals to 0. That is the third equation. When x equals to gamma degree 4, just replace. Fourth equation. And lastly, x is delta. So get delta degree 4 minus 3 delta cube plus 2 delta squared plus 12 delta minus 2 equals to 0. That is equation number 5. Now, to make use of the minus 27, I will just add these 4 equations. Okay, at the same time, I will be getting this summation as well. So, second plus third plus fourth plus fifth, I will get alpha degree 4. Just write down all the summations. Then put a bracket. Now, for the second term, since the minus 3 is in common, then I can just take out the minus 3, followed by the summation of the cube root. The cube of the roots. Okay, then for the third term, the plus 2 is in common, so I factorize the plus 2. And then the next term, the 12 is in common. And lastly, the minus 2, they are 4 times. So minus 2 times 4 equals to 0. So from here, right, this sum to get this sum, all this will be moved to the other side. Okay, so I will get the minus 3 becomes 3. So the summation of the cube of the roots, it will be negative 27. Just replace. So here, negative 27. And then the plus 2 becomes minus 2. And then this, okay, this summation is given in the question, which is 5. Just replace by 5. And then the 12 of the summation of the roots will be negative 12. So that is also given in the question, which is 3. So minus 2 times 4 is minus 8. When you move to the other side, it becomes plus 8. Alright, so from here, the total is negative 119. So that is the solution of this question. Okay, question number 4. The lines L1, L2 have these two equations. Find the shortest distance between L1 and L2. Now, this L1 and L2, when you need to find shortest distance, that means the L1 and L2 will be the skew lines, right? So the diagram is like this. This is your line 1, let's say A, and this is the direction vector B, B1. So this is your B1. This is your B2. So which means minus 4, 3, 5. And then another line is over here. This is your L2. This is L1. So here you will get C. Then this is your B2. That is 2, -3, 1. Now, to get the shortest distance is basically you are counting this. What is the shortest distance here? Which is 90 degrees. Right? And then now here, I can just move it to this side. And then here is the 90 degrees as well. Okay, so now what to do here is to find the distance, shortest distance, right? That is basically from L1, and let this be R1. Okay, so probably I will just write OA. OA equals to -2, -3, -5. Okay, and then the B1 is -4, 3, and 5. Now, for the OC, right? So OC from L2. That's why I label here as C. So this is your OC. It will be 2 minus 2, 3. And then the B2, the second direction vector, 2 minus 3, 1. So now what we need to do is, okay, the shortest distance formula is basically, okay, now here. Shortest distance formula is basically modulus of AC dot B1 cross B2 over modulus of B1 cross B2. This is the shortest distance, right? Perpendicular distance. That means now we need to find out what is your AC first, the vector AC. So therefore, vector AC is vector OC minus vector OA. So just replace accordingly. Vector OC minus vector OA, and you will be getting 4, 1, 8. Okay, now for the B1 cross B2, this is a vector product. So I will write this as -4, 3, 5 times or cross with 2, minus 3, 1. Okay, so now for the cross products, you have two methods. The first one is you just direct use this, or another one is you express in the determinant form. Okay, so I will direct evaluate. So that means for the direct evaluation, what to do is you cover the first row and then the sign is plus. Okay, so for the remaining term, you just use cross multiplication. That is the shortcut. So which means I will get 3 times 1 minus 5 times minus 3. Now for my second component, the J component, is a similar method. So now you cover the second row and then you use cross multiplication. So now when I cover the second row, the sign is minus. Okay, so when you do the cross multiplication, minus 4 times 1 minus 2 times 5. Lastly, the third component, which is a K component, you cover the third row. You cross multiply the other two terms. The other two components. It will be minus 4 times minus 3, then minus 3 times 2. Okay, so this will give you the cross product. So now from here, I will just evaluate. This is basically 3 plus 15, 18. So it's a plus. Then minus 4 minus 10. So I get negative of negative 14. Then plus of 12, minus 4 times minus 3 is 12. 12 minus 6 is 6. That means here I'm getting 18, 14, and 6. That is my B1 cross B2. Okay, so now you refer to this formula. Okay, I will just direct solve right now. So I will continue over here. My shortest distance between L1 and L2. That is determinant. This straight line is modulus to make sure that it is positive. this is the formula. Now, AC is 418 dot B1 cross B2, 18, 14, and 6. Then over square root of the cross product. So 18 square plus 14 square plus 6 squared. Then from here, for the numerator, that is the scalar product. So you just times. So I'll get modulus of 4 times 18 plus 1 times 14 plus 8 times 6. Then over, now the square root here is basically 556, right? Square root of 556. Then now for the numerator, when you add all the values, it will be 134 over square root of 556. So since this is a positive value, so I do not need to write this modular sign anymore because it's already positive. So now you just calculate this value, it will be 5.6829, and correct to 3 significant figures, that will be 5.68. So this is your shortest distance. Okay, now the plane pi contains L1 and the points with position vector. Find an equation of pi, giving your answer in Cartesian form. Okay, now this is the diagram. Let's say this is the pi. Alright, so pi contains L1. So let's say this is your L1. Remember, just now L1 has points A and also the direction vector B1. Now, from here, I will say that my pi has units vector n. Okay, and now the plane pi contains L1 and the point with this position vector. So probably there is a point here. Let's say this is D. So with coordinates -1, -3, and -4. Okay, these are the coordinates. Now, to find the pi, we need to find the n. Okay, so from here, I know that the A joined to D will get another vector. And since both are on the plane, that means now your n is perpendicular to both AD and B1. Okay, so that is how I get the n later on. So which means now I need to find out what is my AD first. So I let OD be -1, -3, -4. Okay, so now my OA from the previous question. So go back to previous part. My OA is -2, -3, -5. So here, -2, -3, -5. Then now I need to find out what is my AD. So AD is OD minus OA. That means this is going to be -1, -3, -4, minus the OA is -2, -3, -5. And hence here, you will be getting 1, 0, 1. Okay, and now since AD and B1 are perpendicular to n, right? So I will say that my n is basically parallel to the AD. This is my AD. So AD cross B1. Okay, that will be perpendicular because the cross product will be perpendicular to both of these two vectors. So now I need to calculate my AD cross B1 first. So my AD just counted 1, 0, 1. Cross with B1, refer to the previous part. My B1 is -4, 3, 5. That is the direction vector from line 1. So again, this is cross product. So now plus of, okay, so cover the first row, then cross product. So it will be 0 times 5 minus 1 times 3. So for the next component, same method as just now. cover the second row, then use a cross product. So 1 times 5 minus 1 times minus 4. Lastly, cover the last column, last row, and use cross product. So I'll get 1 times 3 plus, minus 0 times minus 4. Okay, so from here, I will be getting plus of minus 3, then minus of 9, and then plus of 3. Okay, then here I will get minus 3, minus 9, and 3. And from here, I can factorize the minus 3. Okay, then you get 1, 3, negative 1. And now, when you look at this diagram, and say that n, the vector n, which is a normal vector to the plane, is parallel to AD cross B1. So if parallel means that I can take the simplest form, which means now your n is parallel to, or probably you just write your n. Okay, I continue here, better. So now the n is parallel to AD cross B1. Okay, so that means you can just take the simplest form. Therefore, your n is 1, 3 minus 1. Okay, because they are parallel. And now, in the question is mentioned that plane pi contains, right, contains this point. So I will just take this point for my calculation. So the equation of the plane pi is r dot n equals to a dot n. And now when you look at the question over here, you need to get the Cartesian equation. So I will change my r to x, y, z. Then my n will be 1, 3 minus 1. And then my a is the given position vector. That will be minus 1i minus 3j minus 4k. So minus 1, minus 3, minus 4. And dots with 1, 3, minus 1. Okay, so from here, again, this is dots product. Just multiply and plus all together. Therefore, I will be getting x plus 3y minus z equals to right side, you get minus 1, minus 9, and plus 4 when you multiply. Okay, then here I will get x plus 3y minus z equals to right side is minus 6. So this is my equation of the plane pi. Okay, next question number 5. Let K be the constant. The matrices A, B, C are given by, okay, A, B, C is given that A is singular. Okay, now show that CAB equals to this matrix. Now for information, singular means the determinant equals to 0. Okay, so determinant of A equals to 0. So I will start with that first, right? Because I need to find out what is my K before I multiply CAB. So now, A is singular. That means determinant of A equals to 0. So now, determinant of 1k3, then 2, 1, 3, and 3, 2, 5 equals to 0. So from here, I will fix the first row. Okay, when I fix the first row, now when I consider first column, right, the cross sign is plus, is 1. So the sign will be plus minus plus when you fix the first row. Okay, so now here I will get plus 1 because the cross out is 1. Then the remaining 1, 3, 2, 5, you just cross multiply. So it will be 1, 3, 2, 5 like this. And then followed by considering the column 2. Okay, so here erase. And now I consider column 2. So the cross out is k, and then the sign is minus. Therefore, it will be minus k. And now cross multiply of the 2. You will be getting the determinant of 2 by 2 matrix. Then later I will cross multiply. And now erase the third column, and now erase the second column and consider third column. So the cross out is 3. So that means here I will get plus 3. Alright. Then the remaining terms, it will be 2, 1, 3, 2 and equals to 0. So now to evaluate the 2 by 2 matrix, right? So here I will get just multiply, cross multiply. I get plus 1, 5 plus 5 times 1 is 5, then minus 3 times 2 is 6. So this is cross multiply. Right, you minus this direction. So same for the next one, minus k, then 10 minus 9 plus 3 of 4 minus 3 equals to 0. So the first term is minus 1, and then 10 minus 9 is 1. 1 times minus k, I get minus k. Last bracket, 4 minus 3 is 1. 1 times 3, positive 3. Then from here, just move the k to the other side. Okay, and the 3 move to left side. Then I will get my k as minus 4. So once I get my k value, now I can just expand. Okay, I can just times CAB. So because of not enough space, probably I write here. Now CAB equals to my C is negative 2, 1, negative 1, 1, 1, 3. Okay, my AB, probably I calculate my AB first, then it will be better. Look at here. Okay, CAB, look at here, CAB, the A is 3 by 3. Okay, CAB, this is 3 by 3. The C is 2 rows and 3 columns. Okay, here 2 rows, 3 columns, so 2 by 3, the dimension. The A is 3 by 3. Then the B is 3 by 2 because 3 rows and 2 columns. So basically, you can solve AB first if you want. Okay, then you will get 3 by 2. Then after that, this 3 by 2 and 2 by 3, at last you get 2 by 2 because you cancel off. See here? Here, AB, this AB, at last it will be 3 by 2. This is 2 by 3. Then at last you cancel. So I will solve AB first. Okay, so I solve AB. That will be 1, 2, 3. My k is replaced by minus 4. Wait, let me check. So, okay, I think I missed a mistake here. Okay, no need to... Wait. Right, here. This is k. So this is basically 2 minus k equals to 0. My k is 2. Okay, calculation mistake. Right, k is 2. So when k is 2, so now my matrix A, I have to replace by 2. So it will be 2, 1, 2, then 3, 3, 5, and multiply with the B. 0, minus 1, 0, negative 2, 3, 0. Okay, here I will expect to get 3 by 2 matrix. So it means 3 rows and 2 columns. So here, how do I do it? Okay, basically it's row times column. Then you plus 1 times 0, plus 2 times minus 1, plus 3 times 0. So here, if I do show all the steps, it will be 0, minus 2, plus 0. Okay, after that, followed by row times column. So 2 times 0 is 0. 1 times minus 1 is minus 1. 3 times 0, again 0. Lastly, 3, 2, 5, multiply with first column. So the first one is 0, second is minus 2, and then the third is 0. Okay, now instead of multiplying with first column, now I change to second column. So it means orange color and orange color. So you just multiply. Now 1 times minus 2, I get minus 2. 2 times 3, I get 6. 3 times 0 is 0. And then for the green color, I multiply with the orange color from the second matrix now. So 2 times minus 2, I get minus 4. 1 times 3 is a 3. 3 times 0 is 0. And same goes to the last row. 3 times minus 2, I get minus 6. 2 times 3 plus 6. Then 5 times 0 is 0. Then now from here, I will be getting my AB. Okay, so this is basically minus 2, minus 1, and minus 2. Then second column, you will get 4, minus 1, and 0. That is my AB. Okay, now I need to show CAB. So now multiply with the C. So now my CAB. So now my CAB equals to, my C is minus 2, minus 1, 1. So minus 2, minus 1, 1 for the first row. Second row, 1, 1, 3. So 1, 1, 3. Multiply with the AB. This is your AB. So negative 2, negative 1, negative 2. Then 4 minus 1, 0. Okay, now for this multiplication, alright, use the same method, row times column. So I will get minus 2 times minus 2, 4. Then plus minus 1 times minus 1 is a 1. 1 times minus 2 is minus 2. Okay, and same goes to the next row. So 1 times minus 2, I get minus 2. 1 times minus 1 is minus 1. Then 3 times minus 2, I get minus 6. Then lastly, okay, I cancel this. And now refer to the second column. And multiply. So minus 2 times 4, minus 8. Minus 1 times minus 1 is a plus 1. And lastly, 0. Then for the second row and second column, when you multiply, you get 4 minus 1 plus 0. Okay, so from here, basically you are getting 4 plus 1, 5. 5 minus 2 is 3. Then minus 2 minus 1 minus 3 minus 6, it will be minus 9. Then minus 8 plus 1 minus 7. 4 minus 1 is 3. So that is my CAB. Okay, it is the same as the question. So therefore, shown. Okay, now part B. Find the equations, more than one equation here, of the invariant lines through the origin of the transformation in the xy plane represented by CAB. Okay, so for the invariant lines that through origin, we always start with y equals to mx. Okay, so now this capital Y, you change to capital X and capital Y. The M is actually the CAB because it's mentioned here, represented by CAB. So I will copy this. Okay, this will be my M. Therefore, that will be 3 minus 9 minus 7 and 3. Then my X over here, I will use lowercase letter. So basically, when you multiply the two matrices or two vectors, right? So I will say that this consider two matrices. So I will get 3 times X plus minus 7 times Y. So minus 7Y. Then for the second row and the column, when you multiply, you get negative 9X plus 3Y. That will be my capital X and capital letter Y. So we know that Y equals to mx. Alright, so my capital Y is minus 9x. Look at here. My capital Y is minus 9x plus 3y. And then my x later on will be replaced, this x will be replaced by 3x minus 7y. So then you will be getting minus 9x plus 3y, okay, equals to m of 3x minus 7y. Now, to get the equations, we need to find out what are your m values, because it's mentioned equations, so you should get 2m. Now, I will replace my y, okay, because here you still have y. So, my y equals to mx. Therefore, minus 9x plus 3 of the y is replaced by mx, then equals to m of 3x minus 7 of mx. Right? So, from here, all the x will be cancelled off. Then, you will be getting the equation in terms of m. So now, I notice that the 3m can be cancelled off. So, which means, right, 7m squared equals to 9. So, your m squared is 9 over 7. Therefore, your m is plus minus square root of 9 over 7. Then, here I can split it into two terms. That will be plus minus square root 9 over square root 7. Square root 9 is 3. So, these are my m values. Therefore, my equations will be y equals to 3 over square root 7x, and also y equals to negative 3 over square root 7x, because our formula is y equals to mx. Therefore, just replace the m that you have found, and that will be the equations requested equation in the question. Okay, now part C. The matrices D, E, and F represent geometrical transformation in the xy plane. D represents an enlargement center, the origin. E is stretch parallel to the x-axis, and then the F means reflection in the line y equals to x. Given CAB, okay, CAB that we have found just now equals to D minus E 9EF. Find D, E, and F. Okay, so I give you a short notes first. For enlargement, okay, enlargement with scale factor enlargement, I would say at center 0, 0 with scale factor K. Okay, the matrix is K0, 0K. Okay, so for the reflection, that will be 0, 1, 1, 0. Okay, these two are the special cases. Right, so for the stretch parallel to x-axis, that is always, okay, the stretch is always m0, 0, 1, provided the m is the factor. Okay, the m is factor, scale factor. Now, for your information, okay, I know that CAD is this, so that means now I will write down my D is basically enlargement, so I will just write this. It will be K0, 0K, and then my E, it will be M0, 0, 1. So later I need to find out the M and K, okay? Then my F, it will be 0, 1, 1, 0. Now, CAB is D minus 9EF. So just now we have found the CAB. CAB is basically this matrix, right? Just rewrite this matrix. So it is 3 minus 9 minus 7 minus 3 equals to D. Just replace K0, 0K minus 9 of M001 multiply with the F. So I will simplify the multiplication first. So it will be K00K minus 9 of, okay, so for the multiplication, row times column. So from here, you will get M times 0 is 0, plus 0 times 1 is still 0. Then followed by 0 times 1, the row times column. Okay, second row times first column. 0, 0 is 0. 1 times 1 is 1. Okay, so now refer to the second column. So M times 1 is M, plus 0 times 0 is 0. Then the second row and second column, it will be 0 plus 0. Okay, so from here, I will just combine, I will just simplify the right hand side. It will be K minus 9 times 0 is 0. So I will get K. 0 minus 9 times M minus 9M. Then 0 minus 9 times 1 is minus 9. K times minus 9 times 0 is just K. So now, when you compare, so obviously, look at here, this K is 3. Okay, so I will get K equals to 3. Okay, I think, let me check my CAB. Oh, my CAB, this is positive 3. Right, so I wrote wrongly. I should only have 2 minus. So here, this one, positive. Therefore, even though you refer to this, you still get the same value. Okay, which means now you see here, these two are the same. So now what I need to do is for the other one, it will be minus 7 equals to minus 9M. Therefore, my M is 7 over 9. Once I found the K and M, I will just rewrite my 3 matrices. So my D will be K00K and my K is 3. So it becomes 3003. Then my E will be the matrix of M001. So my M is 7 over 9. So 7 over 9, 0, 0, 1. And then my F remains. That is 0, 1, 1, 0, which is the last matrix here. So 0, 1, 1, 0. So that's all for this question. Okay, question number 6a. Now show that the equation with Cartesian equation has polar equation y equals r equals to cos theta. So from here, we know that x equals to r cos theta for polar coordinates, and then the y is r sine theta. So now I will substitute these two expressions into the equation. Alright, so it will be r cos theta minus half squared it plus r sine theta squared equals to 1 over 4. And at last, I need to prove that it is r equals to cos theta. So do expansion for the quadratic. Now, use this formula to expand. So then you will be getting r squared cos squared theta minus the half times 2 is 1. So therefore r cos theta. Then plus 1 over 4. You square the half is 1 over 4. And for the second bracket, bring in the square to both terms. That will be r squared sine squared theta equals to 1 over 4. Since I have 1 over 4 both sides, means that they will be cancelled off. Alright, and this r squared sine cos squared theta and r squared sine squared theta can be factorized the r squared theta. Sorry, r squared can be factorized the r squared. So you will get cos squared theta plus sine squared theta. Then minus r cos theta equals to 0. Right side no more term. So then we will simplify the bracket using formula or using identity 1. Therefore, I will get r squared times 1 minus r cos theta. And now here I can factorize the r. It will be r minus cos theta equals to 0. Then from here we know that r is the radius, right? R is the length, the magnitude. So not radius, it's the magnitude. Therefore r cannot be 0. So r cannot be 0, which means r minus cos theta must be 0. Hence your r must be cos theta. So this is the equation. Now, the curves C1 and C2 have two polar equations where theta between 0 and half pi inclusive. The curves C1 and C2 intersect at the pole and the other points P. Find the polar coordinates of P. That means now we need to find intersection points. Right, for intersection points, let R1 be R2. So I will just write cos theta is sine 2 theta. And then sine 2 theta, we have a formula. Sine 2a equals to 2 sine a cos a. Which means now it will be cos theta equals to 2 sine theta cos theta. Okay, so I will move the 2 sine theta cos theta to the other side, which means cos theta minus 2 sine theta cos theta equals to 0. And the cos theta is in common. Take it out, factorize out. Then you get 1 minus 2 sine theta equals to 0. Now again, when multiplication of two terms equals to 0 means one of them must be 0. So cos theta equals to 0 or 1 minus 2 sine theta equals to 0. Now look at here, right? Your cos theta because your theta is between 0 and half pi, look at the cos graph. This is a cos graph. Here is 2 pi, this is pi, and this is half pi. Right? So when cos theta equals to 0, okay, so look at here. I would say look at here. It's nothing to do with this graph. So when cos theta equals to 0 means that your R1 equals to 0. Means that you cannot get a graph anymore. So from R1 equals to cos theta, that means cos theta cannot be 0. Okay, otherwise the curve one does not exist because the radius is 0. Okay, so that means obviously, right? So which means 1 minus 2 sine theta must be 0. So when this equals to 0, I will say that my 2 sine theta equals to 1. Therefore, my sine theta is half. Okay, so when my sine theta is half, then my theta, when you refer to the quadrant here, right, so I will get 1 theta value. That is inverse sine half. That means you get pi over 6. Right, so the P with polar coordinates means R and theta. So now your R, okay, so at P, theta is pi over 6. Then the R equals to cos theta. Cos pi over 6 is square root 3 over 2. That means from here I know that, okay, so I don't have enough space, so I just continue over here. So therefore, my P is with coordinates. Okay, therefore my P is with coordinates R theta. That will be R is square root 3 over 2. Then the theta is pi over 6. So that is my coordinates, polar coordinates of points P. Okay, so part C. In a single diagram, sketch C1 and C2, clearly identifying each curve and mark the points P. Okay, so the first graph is R cos theta. So I will let R1 equals to cos theta. Then the second curve, it will be sine 2 theta. And now your theta is defined from 0 to half pi. which means, okay, so if you are not sure how's the graph, you can just construct the table, calculate some values. So since this is between 0 and half pi, maybe you start with 0, then pi over 6, then pi over 4, pi over 3, followed by pi over 2. So now when you calculate, make sure you set your calculator in radians mode. You get 1. So for the R1, okay, I will get 1. Then square root 3 over 2. This is something like 0.9. This is half. Oh, sorry, this is square root 2 over 2, which is 0.7. Then here is half, 0.5, and then 0. So for the other one, it will be 0. Then square root 3 over 2. Okay, it is the same, which is roughly 0.9. Round up to 1 decimal place. And then 1 square root 3 over 2. And then 1. Okay, so now mark all these points. So this is 0. Here is pi over 2. Okay, so now I need to mark. So here I just roughly draw, okay? So pi over 4 is 45 degrees. You need to measure using your compass. Using the protractor, sorry, protractor, not compass. This is pi over 4. And then pi over 6 is half of pi over 4. And then pi over 3. Okay, here is 0. Right, no, here is 0. Now just mark the points. So the first point, 1, let's say. Okay, so here I just roughly, you need to measure. Let's say here 1, then 0.6, 0.9, then 0.7, 0.5, then 0. Okay, so now my C1, I'll just combine. I will just join all the points. Actually, it's a semicircle. So this is my C1. Okay, now my C2. So when you sketch, 0, 0.9. Okay, so here also 0.9. Same point. Then after that, 1. Alright, probably 1 is somewhere here. And then 0.9. Then 1. Okay, sorry, this is 0. Sine pi is 0. Okay, it's not 1. So here is 0. So it means that the graph will be something like this. Okay, the actual graph should be like this. Right, maybe this part I redraw a bit. So that's why you must measure. Okay, here I only simply sketch. Okay, so it should be in this shape. Okay, the other one is a semicircle. Right, so this is your C2. And then since your P is the intersection point, obviously your P is, okay, wait, my graph is not so accurate. Okay, so this is my C1. That means my P is over here. This is my P. Okay, so there's your graph. And remember, my graph is not accurate because I didn't measure. So you please measure and then you will get the accurate graph. Okay, so now, done for this part. D, the region R is enclosed by C1 and C2 and includes the line OP. Find the exact form area of the R. Okay, enclosed by C1, C2 and include. So enclosed by C1 and C2 include the OP. So O is here. So it means that it will be, okay, bounded by C1, C2. This is your R. This is your R. Okay, so for you to get this area, what to do is you have to be careful because your C1 is basically R1 equals to cos theta. Your C2 is R2 equals to sine 2 theta. Okay, based on here, I know that the region bounded by sine 2 theta, which is a blue line, it is from 0, okay, which is here, see here, 0 to pi over 6, right? And then for the green color, it will be from pi over 6 until pi over 2, right? Because all these are green color, right? Look at the graph. So it means that for this R, you need to split it into two integrations. So then my area is basically half integrate R squared d theta. This is the formula. But then since we have two different limits, therefore I split it into two integrations. So this is the blue line, the blue curve is from 0 to pi over 6. So 0 to pi over 6, that is my C2. So sine 2 theta. Then plus half. The other one is pi over 6 to half pi. Then cos theta. Okay, but then look at here, R squared. So you need to square the R. That will be the formula. Now, okay. So from here, before I integrate, I need to bring in the square first. It will be from 0 to pi over 6 sine squared 2 theta d theta plus half of the integration cos squared theta d theta. Now, for the sine squared 2 theta, when you need to integrate, we always refer to double angle formula. So cos 2a is 1 minus 2 sine squared a. Okay, now I need to get the sine squared a as a subject because you need to integrate the sine squared. So move the sine squared to the other side, move the cos to right side. So 2 sine squared a is 1 minus cos 2a. And then now my a is 2 theta, which means my 2a becomes 4 theta. Okay, so I will change to this form first before I integrate. That means this is, okay, half. So now I need to get sine squared. So which means the square, the 2 there, I will move right from here. I will write sine squared a is half of 1 minus cos 2a. So that means it will be another half. So I will write half, then integrate 0 to pi over 6, 1 minus cos 4 theta. Same goes to the cos squared. So now cos 2a is 2 cos squared a minus 1. So now get this as a subject, means you move the minus 1 to the left side. So I will get 2 cos squared a is 1 plus cos 2a. Hence, my cos squared a is half of 1 plus cos 2a. And again, this is cos theta. That means my a is theta. Okay, that means for the second integration, I will write half. That is the original half. And there is another half here. So half, that integrate pi over 6 to pi over 2. Then 1 plus cos 2 theta. Okay, so now you simplify. So it will be 1 over 4. Integrate 1 with respect to theta is theta. Integrate cos is sine. Rewrite 4 theta, then over 4. Because you differentiate 4 theta, you get 4. Close brackets, write down the limits. Plus 1 over 2 times 1 over 2, you get 1 over 4. So the 1 you change to theta. Cos 2 theta change to sine 2 theta over 2. And then limits from pi over 6 to pi over 2. Now, just replace the theta by the upper limits first. You will get 1 over 4 multiplied with pi over 6 minus, this is going to be sine 4 over 6 pi. Sine 4 over 6 pi, you get square root 3 over 2. So square root 3 over 2 divided by 4. Okay, divided by 4. Then minus, when theta is 0, you get 0. Sine 0 also 0. Close bracket. Plus 1 over 4. Theta is pi over 2. Then plus, so sine pi over 2 times 2 means that sine pi is 0. Then minus, when it is pi over 6, right? Then you plus with sine 2 over 3. Sine 2 over 6 pi is sine pi over 3. Sine pi over 3, you get square root 3 over 2. Then divided by 2 again. So now from here, I will get, okay, let me rewrite first. 1 over 4 times pi over 6 minus, okay, I notice that the pi over 4 is in common. So it means that I can combine everything just now later. So it will be pi square root 3 over 8. And then here is pi over 2. And then minus pi over 6. And then minus, bring in, minus square root 3 over 4. Okay, so now from here, I can cancel off pi over 6. So then I will just multiply to get my answer. Okay, so from here, basically you know that the 8 is in common. I mean, I can factorize 8 from the terms inside the bracket. So when I factorize 8, I get 1 over 32. So the first term is minus square root 3. Okay, then the second term, you get 4 pi. Last term, I factorize 8 from 4. That means you will have 2 square root 3. Therefore, the answer is 1 over 32 times 4 pi minus 3 square root 3. That is the area bounded by the L. I would say that the area of the R. Okay, next question, number 7. The curve C has equation y equals to fx, where fx is x squared plus 2 over the quadratic. Find the equations of the asymptote. Okay, so for asymptote, firstly, I will look at the highest degree of x, both also 2. Therefore, I will have horizontal asymptote. How to get horizontal asymptotes? Refer to the coefficient for the highest degree, which is 1 over 1. Therefore, without any calculation, I will get y equals to 1, horizontal asymptote. Y equals to 1. So for the vertical asymptote, I will let the denominator be 0. And this quadratic equation can be factorized into x minus 2 and x plus 1. Therefore, either x minus 2 be 0 or x plus 1 be 0, which means your x is 2 or x is minus 1. That will be my vertical asymptotes. So done for the A. Now B, find the coordinates of any stationary points on curve and give your answer equal to 1 decimal place. So stationary points is basically dy dx equals to 0. Right now, I will copy this. Okay, I let it be y. So let y equals to x squared plus 2 over x squared minus x minus 2. So this is quotient rule. Right, just for information, quotient rule, d over dx, u over v. That is v squared, vu prime minus uv prime. Okay, which means now I will write down my u. My u is x squared plus 2. U prime is 2x. V is x squared minus x minus 2. V prime is 2x minus 1. Therefore, from here, my dy over dx, I will write over v squared. Then I keep the v. Okay, u prime is 2x minus uv prime. My v prime is 2x minus 1. Then now, you can just do expansion. Before we let this be 0, just multiply all the terms. I'll get 2x cubed minus 2x squared minus 4x minus, okay, put the bracket and do expansion. I get 2x cubed. X squared times minus 1 is minus x squared. 2 times 2x, 4x. 2 times minus 1, negative 2. Okay, now simplify the numerator. So 2x cubed minus 2x cubed because you times in the minus. Alright, so here I will get minus 2x squared minus 4x times in the minus, you get minus plus 2x squared plus x squared minus 4x plus 2. Then at last, you are getting minus 2x squared plus x squared minus x squared minus 4x. Okay, here minus 4x is minus 8x. Then plus 2 over the quadratic. Okay, so we can just stop here. And now the question asking for coordinates of the stationary point, which means now dy dx equals to 0. So when dy dx equals to 0, basically it's a numerator equals to 0, right? So I will write 0 equals to minus x squared minus 8x plus 2. So my x squared plus 8x minus 2 equals to 0. And the question says 1 decimal place, right? So which means now I need to solve this quadratic equation. So my a is 1, my b is 8. Probably I just copy down. So x squared plus 8x minus 2 equals to 0. That means my a is 1. That is a coefficient for x squared. My b is 8. My c is minus 2. So my quadratic formula, okay, so ax squared plus bx plus c equals to 0. That means your x is minus b plus minus square root of b squared minus 4ac over 2a. That is my quadratic formula. And now, by using this formula, you will get minus 8 plus minus square root of 8 squared minus 4 times 1 times minus 2. Then over 2 times 1. So, you calculate this. That will be 0.2 and negative 8.2. Okay, and now we need to get the coordinates of the points, which means I need to find with y. So you need to calculate the y value from this expression. So now when x equals to 0.2, my y is x squared plus 2 over x squared minus x minus 2. So x squared plus 2, so 0.2 squared plus 2 over 0.2 squared minus 0.2, then minus 2. This is going to be negative 0.9. Okay, and for the other value, x equals to negative 8.2, just use the same formula. Negative 8.2 squared plus 2 over negative 8.2 squared minus negative 8.2, then you minus 2 because of the function over here, minus 2. Then this value is going to be 0.9. So once you found these two, okay, then you can just write here stationary points with coordinates (0.2, negative 0.9). Okay, and another point is negative 8.2, then 0.9. So that is your final answer. Okay, now see sketch C, stating the coordinates of any intersections with the axis. So now I will copy the function first. So when x equals to 0, that is the intersection with the x-axis, with the y-axis. So it will be 0 plus 2 over 0 minus 2. That is minus 1. Okay, so I get the point. So this point is 0 minus 1. And now when y equals to 0, that means x squared plus 2 equals to 0. So this one no solution, right? Because your x squared cannot be negative 2. So it means no intersection points with the x-axis. Okay, now I have 2 points just now, stationary points. (0.2, negative 0.9, and negative 8.2, 0.9. Okay, my asymptotes, y is 1, x is 2, and x is minus 1. Okay, so now I can sketch based on all this information. So here, intersection with the axis. It will be 0 minus 1. Okay, now sketch. So from here, I know that my x value, I need to cover up to negative 8.2. And then my y value is negative 0.9 or negative 1. Okay, so here. So here 1, 2, 3, 4, 5, 6, 7, 8, 9. One, 2, 3, 4, 5. Then here is minus 1. Then now, I need y equals to 1 asymptote. So draw horizontal line. Using dotted line, this is my x. Then my x equals to 2 and minus 1. So 2 and minus 1. Is a straight line. Okay, so now then, mark the points. 0, minus 1. So when x 0, y is minus 1. This is the intersection. And then now, I have 0.2, negative 0.9. Minimum point, stationary points. 0.2 and negative 0.9. 0.2 is somewhere here, negative 0.9. Probably here. Okay, just roughly. This is 0. And then negative 8.2, 0.9. Negative 8.2, 0.9. Okay, now, the meaning of the dotted line here means when it tends to infinity, okay, it will be approaching this dotted line. That means it will be positive infinity or negative infinity. So all these are my possible graph, the green color. So, but then you must understand that this point is a stationary point, which means based on this diagram, most likely it will be a maximum point, something like that. Alright, then now I will erase here, so no more graphs on top. Okay, after that, you need to sketch. There is a point over here. See, this is a point, and this is a stationary point. Most likely, this is a minimum point. And then, okay, now I have to find out when it is 1 for the y. What happened to my y? What happened to my x? So this will be the extra calculation. So when my y equals to 1, okay, so substitute to this. So y 1 equals to x squared plus 2 over x squared minus x minus 2. So just multiply in. It will be x squared minus x minus 2 equals to x squared plus 2. So the x squared will be cancelled off. Okay, then this minus 2 minus x move to the other side and the 2 move to the other side. So it means that I will be getting x equals to minus 4. So I know that it will cut at minus 4 here. So now, definitely the graph will be like this. Alright, my graph is not smooth. This is a minimum point. Okay, so now here you got to cancel all this. Cancel all these dots. Right? Then here until infinity. Okay, now what happened to the right side, which is greater than 2? So I can just substitute x equals to 3. So this is the extra calculation. Well, x equals to 3, your y equals to x squared plus 2. So 3 squared plus 2 over 3 squared minus 3 minus 2. This is going to be 11 over 4. That is 2.25. So 2.25 when it is 3, that means it's above. So now my graph will be here. Okay, this will be my y equals to fx. So I will label this graph y equals to fx. So done for the graph. Okay, now D, sketch a graph with equation y equals to 1 over fx. So when 1 over fx, you check here. When x tends to -1, right, your y equals to 1 over fx. That means now becomes x squared minus x minus 2 over x squared plus 2. So this is same as x minus 2 times x plus 1 over x squared plus 2. So now what to do is, I will say that when my x approaches, okay, let me check. Right, minus 1. Okay, remember, this 1 over fx is also same as 1 over x squared minus x squared plus 2 over x squared minus x minus 2. Alright, so then I will move it up. Now from here, okay, basically I don't need this. What I need to do here is I need to find out what is my asymptotes. Okay, again my y equals to 1 because of here 1, 1. So my asymptotes will be y equals to 1. And then I don't have any vertical asymptote because x squared plus 2 is my denominator. Okay, then I will find out few points. When you look at previous point, 0 minus 1. So now I will write fx is 0 minus 1. So now change to 1 over fx. That is 0, 1 over minus 1. That is 0 minus 1 as well. Same point. No difference. Okay, then now for the stationary point, alright, so 0.2, negative 0.9. When it changes to 1 over fx, then this becomes 0.2, 1 over negative 0.9. Then this is roughly negative 1.1. So same goes to the other points, minus 8.2, 0.9. So when it comes to 1 over fx, it becomes negative 8.2 and 1 over positive 0.9. Okay, because the concept is just take the 1 over reciprocal. Then this is 8.2, 1.1. And now just now I found 1 point. See here? Minus 4, 1. Okay, so minus 4, 1. It will change to minus 4, 1 over 1. That is minus 4, 1 as well. Okay, so now when my y equals to 0, okay, so when my y equals to 0, I'll do it here. When my y equals to 0, y equals to 1 over fx, right? That means x minus 2 times x plus 1 over x squared plus 2 equals to 0. So I will get x equals to 2 and minus 1. So I get 2 points now. So now with all this information, I can start sketching my graph. So my x is up to 8.2. So here 1, 2, 3, 4, 5, 6, 7, 8, 9. Then my x is, okay, 1, 2, 3, few points. Then my y value is until 1.1. So let's say here 1, here is 2. Then here minus 1, minus 2. Now first of all, I will sketch my asymptote. Y equals to 1. Then I will mark my points. 0, -1. I use the blue color. 0, -1. This is my point. 0.2, -1.1. No, 0.2, -1.1. Probably here. Then 8.2, 1.1. 8.2 or positive. Is it positive? Oh, sorry, this is negative 8.2. So here should be negative. Negative 8.2, 1.1. -4, 1. Okay, after that, I get 2, 0. When x is 2, y is 0. Then when x is -1, y is 0. Alright, now when you draw the dotted line means that you might get these graphs. Okay, then from here, right, I know that these two are stationary points. Stationary points. Which means, even though you take the 1 over, it is still the stationary points. Alright, so just now, it looks like this one positive value is a maximum. So now this becomes minimum. Okay, the maximum one becomes minimum, and then this becomes a maximum because of 1 over. So now I know that here is my minimum point. Negative 1.1. Then did I mark wrongly? Okay, this one becomes my minimum point. Okay, based on here. And the other one is the maximum. So this is my maximum point. Right. Let me check. Okay, if it is a maximum point, okay, here. Negative 8.2 and 1.1. Right, from here it looks like this is a minimum point. And then here is maximum. Okay, this is maximum. So here going down, close to this asymptote. Then here cut, then intersect, and this one going up, and now intersects with the 2 here, and going up. Looks like this, the graph. Okay, this one not going up, just tends to infinity, tends to the line. So looks like this is your y equals to 1 over fx. Okay, so this is the graph. Now, part E, find the sets of values for which 1 over fx less than fx. Okay, so now we need to compare both graphs. Look at here. When 1 over fx less than fx, now from here you look at this. Right, when it is -4 less than -4, here less than -4, your 1 over fx is positive. Okay, and then this is negative, right? It is less than 1. The y value is less than 1. Then this is greater than 1. See the graph? That means 1 over f inverse is not less than fx for x less than 4. That means no solution over here. And then now from -4 to this value. Okay, this value is basically 0.2. So from -4 to 0.2, let's check. So from -4 to 0.2, 0.2 is over here. Okay, your fx is above the y, above 1 when it is between -4 and -1, and then from -1 to 0.2 it is between 0 and -1. That means now when you check here from this part up to 0.2, okay, so the graph is basically less than that, right? 1 over fx is less than that. So now I need to find out what is the intersection point first. Then again from 2 onwards, you see the 2, it touches at 2, so this is always below 1, right? It's between 0 and 1, but for 2 onwards this graph is greater than. Okay, that means now basically we need to find out the intersection points when 1 here, right? And also -1. What happened to the intersection? So now what to do is I will just solve this original graph and let it be 1 first to find out the intersection points. So now x squared, so x squared fx equals to x squared plus 2 over x squared minus x minus 2 when fx equals to 1. So x squared plus 2 over x squared minus x minus 2 equals to 1. And the other one is when fx equals to -1. I need to find out the intersection points. Okay, so from here, I will get x squared plus 2 equals to just multiply to the other side. Then the x squared will be cancelled off. Alright, this minus x move and this 2 move to the other side. That means my x is 4. And then for the other part, it is x squared plus 2 equals to negative x squared plus x plus 2. So the negative x squared will move to the other side and then the 2 will be cancelled off. That means now you are getting 2x squared equals to x. So I will say 2x squared minus x equals to 0 means that your x, when you factorize the x, it will be 2 minus x equals to 0, which means your x will be 0 or 2. So now, okay, wait, okay, mistake. This is 2x minus 1. That means you are getting half. That means now, when fx equals to 1, I get 4. Okay, go back to the fx. I get 4 here. Then when fx equals to -1, okay, I get 0 and half for the x. So here is 0 and half. That means here is half. Right, here is half. So now I want to find out my interval. So you see, I have found -4 just now. Alright, so now you consider when it is between -4 and -1. Okay, here -4 and -1, because -1 is the intersection is the asymptote. So my graph, my green color, my fx is above 1, right, or 1 and above. But then when you refer to here from -1 to -4, my graph is below. That means 1 over fx less than fx okay, my x between -4 and -1, it will be less. Okay, and then what happened when it is 0 and half, or between 0, okay, between -1 and half? Just now I found -1 and 0. Okay, -1 and 0, look at here. -1 and 0. My fx is from -infinity until -1. So now here, from -1 to 0, so now from -1 to 0 here, okay, my graph is between 0 and -1. So 0 and -1. Here it will be negative infinity until -1. That means my fx is less than 1 over fx. Okay, that means cannot be accepted. Now what happens if I consider from 0 to half? because our intersection 0 to half. So when 0 to half, that means you are considering this part. So it will be between -1 and this is minus 0.9, okay, for fx. So, but then when it is from 0 to half, let's say this is not half, this is 0.2, half is over here. So from 0 to half, right, 0 to half, my graph is below, see, less than -1, right? So which means here it is 0, it is between -1 and 0. Just now, my 1 over fx, when you compare, it is less than -1. That means this is my solution. So 0 and half. Okay, and now I need to count. I need to consider the other asymptote, which is this part. From 2 onwards. From 2 onwards, my green color graph, it is above y equals to 1. Okay, but then when you refer to 2 onwards, my graph here 1 over fx is below 1. Alright, therefore the 1 over fx is less than fx when it is greater than 2 for the x values. So here I have to write x is greater than 2. Okay, so you have to compare the both graphs to get the answer of last part. Alright, so that is the solution of this question. Okay, we have solved the whole paper, and also this is the end of the video. Thanks for watching. If you enjoy watching my video, please like and share this channel with your friends. And if you would like to show your support to this channel, you may just click the thanks button below the video. Okay, and stay tuned for more upcoming videos. Thank you. Bye.